Hello everyone, welcome to the next lecture in Theory of Computation, and in this lecture we will be discussing about some of the operations on regular languages. Alright, so let's get started. Okay, so here are the operations that we are going to discuss: union, concatenation, and star. So let's start with union. So the formal definition of union is given here. A union B is equal to X such that X belongs to A or X belongs to B. So this union operation is exactly the same like you perform your union operation on sets. So suppose you have two language sets, namely A and B, then the union of A and B would actually mean anything X such that X could either belong to the set A or it could belong to the set B. So it basically means everything from A and B. Okay, that is union. And coming to the next one, that is concatenation. A concatenation B. Concatenation is denoted by this small circle and it is equal to xy such that x belongs to A and y belongs to B. This basically means that joining two symbols together. When you join two or more strings or symbols together, that is what we mean by concatenation. So suppose you have x, which is an element of A, and y, which is an element of B, and you join them together like this, xy. That is known as concatenation. And the next one is star. So star operation, unlike union and concatenation, in star operation we have only one set. So performing the star operation on set A means x1, x2, x3 up to xk such that k greater than or equal to 0 and each x of I belongs to A. So don't worry about this long definition. It only means that you take as many symbols that you want from your set A and you just join them together in any way you like. That is what you mean by star. So all these three will become more clear when we take an example that we are going to do below. That will make it even clearer. Alright, so let's take an example. So here I'm taking an example where I have two sets A and B, where A is equal to a set where I have the elements P, Q, and R. And then I have another set called B, which also has two elements T and UV. So we have these two sets, and let's perform union, concatenation, and star on these two sets. So first of all, let's perform union. A union B. What would this be? So A union B, as we saw in the definition, X such that X belongs to A or X belongs to B. So basically it means everything from A and B. Just put all these elements together from A and B. So from A we have P, Q, and R. And from B you have T and UV. T and UV. So this is the union operation. Everything from set A and set B put together. That is the union operation. And coming to the next one, we have the concatenation. Concatenation of A and B. So what is the concatenation of A and B? So as I told you, concatenation means joining two or more symbols or strings together. So here in A we have P, Q, and R, and in B we have T and UV. So I should join XY such that X belongs to A and Y belongs to B. That means one element from A and another element from B should be joined. So how can I perform the joining? I could join PQ and T, PQ and T. I have joined them together. That means I have concatenated it. Then in the same way I can join PQ and UV, PQ, UV, and in the same way I can join R and T, R and T, and then I can also join R and UV, R and UV. So here we have performed the concatenation of A and B, where the first element is from A, second is from B, and we have joined them together. So that is the concatenation. And coming to the last one, which is star operation, A star. So what is A star? So as I told you, in star operation there is only one set involved. So A star means I can take as many symbols from that set and I can join them together in any way I like. So I'm dealing with A star. So in A star, what are the elements that I can have? So I would first write epsilon. Epsilon, as I already told you in the first lecture, it means the empty string. So empty string also is a part of A star. Alright, and the second one would be PQ just by itself. I can write it, and R just by itself. Alright, now let me join PQ and R. I can join PQ and R, right? I can also put R first and then PQ, R and then PQ, or I could join PQ with itself, PQ, PQ, or I could join R with itself like this, R, R, or I could join PQ three times, PQ, PQ, and PQ, or I could even, oh sorry, there should be no comma over here. This is PQ, PQ, and PQ, means I'm joining it together. And I can also join R three times, R, 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 and it goes on. This actually will be an infinite set. It could have infinite number of elements. So that is how we perform union, concatenation, and star. Alright, so I hope this was clear. Now there are two important theorems that you need to remember, which I will be discussing now. Alright, so here are the two theorems. The first theorem says that the class of regular languages is closed under union. So what does this mean? This means that if you have two regular languages, let's say suppose A and B are two regular languages, and if you perform the union of A and B, you perform the union of A and B, which are regular languages, then the union of A and B is also a regular language. That means the union of two regular languages is also a regular language. That is what it means. And then the second theorem says that the class of regular languages is closed under concatenation. In the same way, if you have two languages A and B which are regular, and if you perform the concatenation of them, then the concatenation of those two languages will also be regular. The concatenation of two regular languages will also be a regular language. So that is the meaning of these two theorems. So I'll not be doing the proof of these two theorems, and if you want the proof, you can leave a comment in the comment section below, so I will be discussing it in a later lecture. So I hope this were clear to you about the operations that we perform on regular languages, which are union, concatenation, and star. So thank you for watching, and see you in the next video.